Okay, for question number 1, which of the following is an equivalent form of the expression 15x plus 24ax? So, let's see, I'm going to just show my work right here. So the first thing I want to point out is the coefficient of 15, the coefficient of 24. Those are both multiples of 3. 3 times 5 is 15. And let me pull up one more thing here. Oh, and 24 is also a multiple of 3. But actually, they did not factor out the 3. So the only thing that got factored out, it looks like, is the x. You have a common factor of x. So if I factor out that x, that would give me x times, so x times what would be 15x, that would be 15. And then x times what would give me 24ax, that would be 24a, and it would be positive. So it's actually D. I was thinking they were going to take out the 3, but they didn't. Okay, number 2, the formula distance equals rate times time is used to calculate the distance an object travels over a period of time t at a constant rate r. Based on this formula, what's the rate r in terms of d and t? So you are solving for r, starting with distance equals rate times time. So if I want to get r by itself, think about it. If you had something like 10 equals 5x, and you were getting x by itself, you would divide both sides by 5, right? Here you want to get r by itself, so you're going to divide both sides by t. So r equals t divided by t is 1, distance over time. So that's A. Number 3, which of the following ordered pair satisfies both equations? So you could literally plug in 0 for x, and if you get -4 for y, then, and if you get that for both of these, that's one way of doing this. You could do it that way. Now, I'm going to show you both possibilities. Okay, so I'm going to show you both ways. And I may just show solving this system of equations. So these are 2 equations, but this is not written in terms of y. So I'm going to get y by itself first. Because when we were solving systems last year, remember, one way to solve a system of equations is substitution. So we're actually going to just set this equation or this expression equal to this expression, because both of those are equal to y. So let's see, we've got, so this is number 3. Okay, so be careful. You know, you might see something like this. Be careful, make sure that both equations are in terms of y. You'd probably recognize it because you'd start to write an equation with 2 variables. If you got 2 variables, then you got an infinite number of solutions. If you got 1 variable, you got 1 solution. Okay, so let's get all of our terms on one side. Subtract x from both sides. And let's go ahead and subtract 4 from both sides while we're at it. That would give me x squared minus 2x. 3 minus 1 is 2. Minus 8 equals 0. And we know how to solve that. I'm going to try factoring using area diamond. So I'm looking for factors of negative 8x squared that add up to negative 2x. So that would be 4x and 2x, and I want the 4 to be negative, so that when I add these two together I get a negative 2. I still get a negative 8 when I multiply them. Okay, now I'm going to write the length and width. Okay, so then I have x minus 4 times x plus 2 equals 0. So then x minus 4 equals 0. This is zero product property, or x plus 2 equals 0. So either x equals 4 or x equals negative 2. So there's two solutions, but you can only choose one. It says which of the following satisfies both equations. So I'm looking for an x coordinate of 4 or negative 2. Uh-oh. I wrote this initial expression wrong. This was x plus 4. No, I wrote that right. X plus 4. Okay, I actually wrote this wrong. 3x minus 1x is positive 2x. So actually, I want the 2 here to be positive, which is going to change the signs on these. So I want the 4 to be positive and the 2 to be negative. So that would be x minus 2 instead of x plus 2. So x plus 4 equals 0 would give me x equals negative 4. And x minus 2 equals 0 would give me x equals positive 2. Okay, there it is. So these are the two solutions. And the only one that is a choice is B. And if you substitute 2 in the place of x here, you get 2 squared plus 3 times 2 minus 4. So that's 4 plus 6 minus 4 would be 10 minus 4 would be 6. If I plug in 2 in the place of x right here, I get 2 equals y minus 4. If I add 4 to both sides, I get y equals 6. So the only one that works is 2, 6. Okay, number 4, which of the following is the solution to this equation? So another quadratic. Okay, so let's get all of our terms on one side of the equal sign. I'm going to move everything over here, just because I know if I subtract 2x squared from both sides, that's going to give me 1x squared on this side. If I take away 4x from both sides, I'm going to write it in order. So that's going to give me 1x squared minus 4x plus 3 equals 0. And then I'm going to try factoring using area diamond. So I'm looking for factors of positive 3x squared that add up to negative 4x. So I want 3x and 1x, and I want them to multiply to give me positive 3, but when I add, I get negative 4. So that's going to be a negative 3 and a negative 1. So that's going to be negative 3x and negative 1x. So that's x minus x times negative 1 is negative x times negative 3 is negative 3x. So x minus 1 times x minus 3 is 0. So x equals 1. If I set this equal to 0, x equals 1 or x equals 3. Zero product property. I'm just skipping writing the equations. So my solutions are 1 and 3, but the only choice that I have here is 3. So 3 is a solution to that quadratic equation. So I'm sure you're noticing that you know how to do this, but you didn't necessarily know, maybe you didn't know how to do this. So that's a good thing for us to practice here. Another system of equations on number 5, if xy is the solution, what's the value of x? Now this is going back to linear equations. I'm going to write this out. And when we did systems of equations last year, we haven't reviewed this very much, so this is good review. One of the ways that we solved the system was elimination. Substitution, elimination, and now that I'm looking at it, I'm thinking substitution might be easier, or graphing, but this was the no calculator part, so you couldn't, well, you could have graphed it, but you didn't have graph paper necessarily. Okay, so I'm thinking substitution actually might be the best route to go here. With substitution, you want to get an expression for x or y. So if I add 10y to both sides here, that would give me x equals 16 plus 10y, or 10y plus 16. And then I could just substitute that in the place of x. So that would give me -3 times, and instead of writing an x, I'm going to switch that x out for, let's go ahead and put the 10y first. I don't think it really makes a difference. 10y plus 16 minus 4y equals 20. Whoops. And let's solve for y. So that would give me, and this is kind of a, I don't know, you're under pressure with time. When I did this, when you were taking the test, I used elimination, but it involved quite a bit of fractions. So that's why I'm doing it this way. I'm distributing that -3. Okay, -30y, -4y would be -34y, minus 48 equals 20. Add 48 to both sides. Divide by -34, so y is -2, and then if I just plug in, because the question didn't ask for y, it asked for x. So I'm going to plug in -2 in the place of y. You could just plug it in really anywhere. This would be a good place to plug it in, because then you're going to get x. That would be 16 plus 10 times -2. So multiply first. So that's going to be -20 plus 16 would be -4. So x is -4. Okay, for number 6, the equation y equals 36 plus 18x models the relationship between the height, y, in inches of a typical golden delicious apple tree, and the number of years x after it was planted. So a very typical linear problem. You're looking at the time in years and the height in inches, and it says if the equation is graphed in the xy plane, what is indicated by the y-intercept of the graph? So your y-intercept is your starting point. You're talking about a tree. So I wrote this out because it can get a little confusing when you're looking at all these 4 choices. You might be tempted to pick one that's wrong. Your y-intercept is going to be the value of y when x is 0. Well, you should be able to pick out your y-intercept just looking at the equation. It's 36. So at 0 years, this tree is 36 inches. Now I'm doing that in my head before I look at these choices. It's not the age of the tree. it's the height of the tree when it's planted. It's not the years. And it's this says number of inches a typical apple tree grows each year. That would be the slope, how much is growing per year. So that would be B. Okay, number 7. I hope you're finding that you actually do know how to do a lot of these questions. Just the time pressure is a lot. It is tough. Giovanni wants to buy shirts that cost $19.40 each, sweaters that cost $24.80. An 8% sales tax will be applied to the entire purchase. If he buys 2 shirts, my shirts are $19.48, so he's getting 2 of those. Which equation relates the number of sweaters purchased, P, so sweaters cost $24.80, and we don't know how many he's buying, we just know he's going to get P sweaters. So which equation relates the number of sweaters purchased and the total cost? Okay, so we know 1940 times 2 is going to be $38.80. Now, you may not have been able to do that as quickly in your head, but if you just quickly multiply, you could just multiply 20 times 2 and subtract $1.20. You could think of it that way, because you're subtracting 60 cents plus 60 cents. But anyway, 2 shirts is going to be $38.80. P sweaters is just going to be $24.80 times P. So I'm looking at this one. This looks correct. This could be it. Actually, all of these have that expression. Okay, so the 8% sales tax is where you have to be careful. If you're going to add 8% to this, you're going to find 8%. You're going to say whatever your total amount is, whatever your $38.80 plus $24.80p times 8%, which is 8 out of 100, or 0.08, you're going to multiply that by your total cost, and then you're going to add it to the original amount. This is just going to give you the tax. So I don't know if you remember this from when we were doing exponential growth, but it would be 1.08 times the total cost. So some of these are a little tricky. It's not 92 cents times the total cost. It is 1.08 for 1.08%. So that would be A. So that was a lot of explaining. I could go further on that if that's confusing, but I think just to try to get through as many of these as possible, I'll move on. But if that's confusing for you, we can go over that in more depth one day after school. 8. A line is graphed in the XY plane. If the line has a positive slope and a negative y-intercept. So we have no idea what this y-intercept is, we just know it's negative, and we know the slope is positive, so it's going uphill. If the person is walking along that incline, along that slope, they're going uphill. Which of the following cannot lie on the line? Well, if you look at this, -3, -3, that could be on the line. -3, +3, there's no way this point could be on this line if it's got a negative y-intercept and it's going uphill. 3, -3, that could be on the line. 3, 3, that could be on the line, because we don't know how steep it is, we don't know where it started. All of these are possible. This is impossible. B. Number 9, a parachute design uses 18 separate pieces of rope. Each piece of rope must be at least 270 centimeters and no more than 280 centimeters long. Which inequality represents all possible values of the total length of the rope, in centimeters needed for the parachute. So then I need not just the 270 270 for each piece, I need 18 times 270. Well, you don't have a calculator on this, so you might be thinking, how am I going to do this quickly? I mean, you could quickly multiply it, but you could also look at these. You could eliminate A, and now you might be looking at these and going, well, it's probably B or C because those both have a minimum value. Let's just go ahead and do 270 times 18 really quickly. And when I'm doing this, if I'm in a rush, I'm not going to do it the long way. And I know you guys use that lattice method. I'm going to do 270 times 10 because I know what that is really quickly. And then I'm going to do 270 times 8, which I guess is just doing it the long way. 16, 21, 60, and then I add those two together real quick. Okay, so I know the lowest value is 4860, and you can look at these two choices. You know the highest value is probably not going to be 4870. It's going to be 5040. I mean, you could kind of just guess on that and probably guess correctly. So that one's kind of just a quick multiplication problem. Okay, carpenter has $60 with which to buy supplies. The carpenter needs to buy nails and screws. Nails cost $12.99 a box, screws cost $14.99 a box. If N represents the number of boxes of nails and S represents the number of boxes of screws, which of the following systems of inequalities models this situation? So last year we didn't get to inequalities, but it's kind of the same when we did systems of equations. He's got $60 and he's going to buy the nails for $12.99 a box. So if you look at these, all of these say $12.99 N and $14.99 S. So we know that's the expression for the nails and screws together, and he doesn't want to spend more than 60. So that means it's not going to be greater than or equal to 60. It's going to be less than or equal to 60. So we can eliminate A and C. It's going to be one of these, either B or D. If N is the number of boxes of screws and S is, these are boxes, N is the number of boxes of nails, S is the number of boxes of screws, then he's not going to buy less than one box for the number of boxes of nails and screws together. The number of boxes of nails has got to be bigger than or equal to 1. The number of boxes of screws has got to be bigger than or equal to 1. So that would be C. Oh wait, less than, sorry. Oops. The one that says less than 60, this one. So number of boxes of, there we go. Okay, for 11, this one is a challenging problem. It was challenging when we were doing similarity. I'm going to separate, first I'm going to look at these two triangles because it's asking me about this ratio, so I need to see if I've got some similar triangles. I've got a 28-degree angle here and a 28-degree angle here. I also have, this is kind of hard to pick out, but this angle is in the little triangle and it's in the big triangle. So when we were doing this in class, I made you draw these separately because, now granted you're short on time, but okay, so this is A, B, C. Here's 28 degrees and here's the angle that I have in common. Now, some of you could do this without drawing them separately. That's fine. I'm doing this more for explanation and review, but it's also one where I find that students can get confused if they don't draw them separately. So it says, which of the following ratios has the same value as AB over BC? Okay, AB is across from the angle that has the arcs on it, that I know is equal to the shared angle, this one right here. So I'm going to look in this triangle. These two triangles are similar. They're similar by AA. They have two angles that are equal. So AB is going to correspond to BD. So BD is going to be my numerator, and then BC is across from the 28-degree angle. So that is going to correspond to DC. So BD over DC would be choice A. And I would say for homework, draw those triangles separately. That's a good typical PSAT problem. Number 12 may have intimidated you because we haven't done much with exponents recently. We're about to. Okay, if the equation above, where A is a constant, is true for all positive values of x and y, what's the value of A? Okay, so let's simplify all of this. X squared y to the third raised to the 1/2. Now we're about to do this coming up in chapter 6. So when you are raising a power to a power, you multiply the exponents. So I'm going to do 2 times 1 over 2. 2 times 1 over 2 is 2 over 2, which is 1. So this is 2, whoops, this is x to the first power. Y to the third raised to the 1/2. 3 over 1 times 1 over 2 is 3 over 2. So this is y to the 3 over 2. That's being multiplied by, let's do x squared raised to the 1/3. That would be x to the 2/3. Y to the third raised to the 1/3 would be y to the first power. Okay, now when I'm multiplying exponents, I add the powers. So I'm going to add whatever this is, which it's 1 to 2 over 3, which means I need a common denominator. I'm going to use a denominator of 3. So 1 is the same over 3. So 3 over 3 plus 2 over 3 is 5 over 3. Okay, same thing here. I'm going to add 3 over 2 and 1. 1 is the same with a denominator of 2 as 2 over 2. 3 over 2 plus 2 over 2 is 5 over 2. So it's asking what A is. A must be 5. For 13, if this equation is graphed in the xy plane, what's the x-coordinate of the vertex? Okay, I'm going to do this quickly. It has already been factored. So I'm going to use zero product property to get the why did I put parentheses there? I don't know. Okay, zero product property would be x equals 6, x equals negative 12. Now, if you were taking the test, I would not expect you to write that out, but maybe you need that for now. So my two x-intercepts are 6 and negative 12. Now, I'm writing all this out as much as you can skip when you're under pressure. Skip it. Okay, from negative 12 to 6 is 18. Half of 18 is 9. So I know my vertex is going to be 9 units over from 6 or 9 units over from 12. So whichever one is easiest for you to think about, that's going to be negative 3, because from negative 3 to 6 would be 9. From negative 12 to negative 3 would be 9. So that's all we had to do. So the x-coordinate would be negative 3. For the grid-in questions, I kind of need to refresh my memory on this. I think our grid-ins are never going to be negative. You don't have to write your answer up here, but it's a really good idea because when you're bubbling in, you don't want to make a mistake. So no question is negative. You'll never get a negative for a grid-in question. and you might have more than one correct answer. Grid in only one answer. Mixed numbers can be gridded in as a decimal or an improper fraction. Don't put 3.5 into a grid in. It's not going to count it as 3.5. It's going to see that and count it as 31/2. If you get a decimal with more digits than the grid can accommodate, it may be either rounded or truncated. That means to cut it off, but it has to fill the entire grid. So if you get something like 0.6 repeated, you could do this or this, round it off, or just cut it off, or just write 2/3 if that's what you get. Doesn't matter if I start on the left or the right when I write my answer. Okay, so be careful. 7/12 would be like this, 2.5 would be like this. Okay, so 14. In the equation above, a is a constant. For what value of a does the equation have an infinite number of solutions? Well, let's go ahead and distribute the 7. So 21x plus 14 equals 21x, okay, plus 7a. For what value of a? Oh, okay, well, for it to be an infinite number of solutions, this would have to be equal to this. So remember, I don't know if you remember when we were solving systems, if the two lines intersect, that's one solution. If they never intersect, that's no solution. And if the lines are right on top of each other, which happens sometimes, then that's an infinite number of solutions, because all of the points that satisfy the first equation also satisfy the second equation. So 14 would be equal to 7a, so a would be 2. That's pretty easy for a grid-in question. I mean, these grid-in questions aren't necessarily hard. Julianne practiced her dance routine for twice as many minutes on Monday as she did on Tuesday. So Monday, whatever she did on Tuesday, she's doing, however many she did on Tuesday, she's doing double that amount on Monday. She practiced her routine those 2 days for a total of 2 hours and 15 minutes. So let's call the amount from Tuesday x, the amount from Monday would be 2x, and it says the total for the 2 days is 2 hours and 15 minutes. That means we need to put this in minutes. 2 hours, 60 minutes is an hour, so this would be 120 minutes plus 15 minutes, which would be 135 minutes. So 2x plus x equals 135. How many minutes did she practice on Monday? 3x equals 135. Divide by 3, x equals 45, so she did 45 minutes on Tuesday and she did 90 minutes on Monday. Number 16. If 3x plus 4 is a factor, what's the value of a? Okay, so if 3x plus 4 is a factor, then 3x plus 4 times something is going to give me 12x squared plus something times x minus 20. So it's kind of like doing an area model, but you only know one dimension. You only know the length. So 3x times 4x would be 12x squared. 4 times negative 5 would be negative 20. 3x times negative 5 would be negative 15x. 4 times 4x is 16x. When I combine like terms, negative 15, positive 16, that would give me 1. So this is 12x squared plus 1x minus 20, so a is 1. Number 17. Okay, a, b, c, and d are non-zero constants. AD equals BC. AC is 18, BD is 50. What's the value of the coefficient of the XY term when the expression is multiplied out and the like terms are collected? So this is just an area model. Looks a little strange because you're not used to having all of these letters, but nothing difficult. AX times CX would be A times CX squared. CX times BY would be BCXY. AX times negative DY would be negative ADXY. And then BY times negative DY would be negative BDY squared. Okay, what is the question? What is the value of the coefficient of the XY term? Okay, so they want to know what's going to happen when we combine like terms here. This is my x squared term. This is my y squared term. If I combine these two, my xy terms, I would have negative AD plus BC. Well, it told me that AD is equal to BC. So guess what? Doesn't matter what this is. If these are equal, you have a negative value and a positive value. When you add those together, you get 0.